Good morning, Angela.
Good morning.
So you got a new phone, huh?
Yes, thankfully.
That's a terrible thing to be without your phone. I've come close to
It
losing. I've almost lost mine a few times, and man,
Oh no.
talk about panicked situations. All right, let's see. The next section is percents. And I actually thought about skipping this because I've always thought percents are not that hard. But I read some of these questions and it's harder than I thought. So we should at least cover some of these.
Okay.
Maybe not to the end, but once if you can set it up, we can go on quickly. Is that big enough? It looks like I could stand to increase it just a hair. There. Angela, you still there?
I'm still here.
Oh, okay, good. Okay, so number one.
That one would be 84%.
Okay, number two.
Let's see. $59.85.
Okay. Number three.
Oh boy.
And look at all the answers. They're all in percent.
Okay. Okay, would I start at the 30%, 20% of 30%, and then 10% of 20%?
Well, usually percents don't go in equations very well. So we need to convert it to decimal. So let's start with the 10%.
Okay.
Times 20% times, and because all the answers are in percent, we're not going to convert that to a decimal because we'd end up with a decimal. I guess we could, and then, in other words, I could put 0.3 there, find out what that decimal is, and then convert it back to a percent. But there's no real reason to. I can write 30% as if it's 30 apples. Okay, what's 0.1 times 0.2?
That's going to be 0.02.
Times 30%. So what do I get?
See, with doing it with the percent, I'm coming up with 60.
Well, I would multiply the 2 times the 30, but then I got to go 2 decimal places left. So I would come up with 60%, move 2 decimal places left because of these 2 decimal places.
Okay.
So I get 0.6%.
0.6, okay.
Now, it might perhaps have been a little easier to do this. And you get 0.006 as a number. And then to convert this decimal to percent, we move the decimal point 2 spots to the right, and we get 0.6%. That actually almost seems a little easier for me to see it. I don't know. if C is a positive number, 500% of C is what percent of 500C? They got to do something to make these hard, because in general, percents are pretty easy. It's usually just moving a decimal point two spots in one direction. So they've tricked these up a little bit.
Yeah, they have.
Let's try to put this into an equation. 500% of C is equals what percent of 500C?
Okay, I'm not doing it here. I'm just staring at this one.
Okay, 500% of C is 5C equals what percent of 500C? Okay, well, the C's cancel. X is equal to 5 divided by 100. So that looks like X is 0.01. But they want what percent. If X is 0.01, that's 1%. Now, let's look at perhaps an easier way than writing this out as an algebraic expression would be to maybe back solve it. We still have to get this far, though. I can replace that with what percent times C, 500C. So as long as you can write this, now we can go in and back solve it. Well, let's start with 0.1. If I took 0.1% of 500, I would get 0.5C. In other words, if I say, okay, 5C is equal, I'm going to back solve it. I'm going to start with the second lowest. 0.1% of 500C. The 0.1% converts to 0.001 times 500C, and that would equal 0.5C. So I would have 5C equals 0.5C. I know that 0.1 is not correct.
Okay.
And I know it's too low.
Right.
It's got to be higher. So let's try 10. 5C is 10% of 500C. Well, 10% converts to 0.1, and then that would make it 50C. So 10 has to be too high. So the answer, therefore, has to be 1.
Okay.
And this, actually, I think back solving is the correct way to do this problem, but you still have to be able to formulate that as a starter. In other words, you have to take the words that you're seeing and convert it to an equation. Even if it's...
Yeah, I think I have a hard time doing that.
Well, a lot of people would here because it's not a typical looking equation. We can certainly get 5C. 500% of C is 5C. But then we've got equals what percent. Well, we rarely see that in an equation. What percent of 500C? You know the of is multiplication. In other words, ofs are multiplication, ises are equals.
Okay.
Okay? So if you can get it formulated like this, now back solving it becomes pretty trivial, as long as you can convert between percents and decimals. So that's the key, the super key ability you have to have, is how to convert between percents and decimals. Now, this one I found particularly difficult. So let's write an equation just like we just wrote. What percent of 50 is B?
Okay, so 50 times percent equals B.
Yeah, B equals what percent times 50? Well, let's make what percent say X, and whether I say X or X over 100, if X is the decimal, and here again we have a word problem that's important to define our variables, X equal fraction fractional. So that when I go to solve my equation, what percent of 50 is B? Okay. Well, if I solve, let's not spend too much time on this problem because this is worded so strangely that I doubt you're going to see it a lot. But if we solve for X here, we get X equals 2B. And that's the answer. In other words, E is 2B. X equals 2B. What percent of 50 is B? 2B.
Okay.
Okay, so in other words, I could rewrite the problem now to say that B equals 2B percent of 50. In other words, that's, and then to convert the 2B percent into a number, it would be B divided by 50. So it's actually clear. Once you know the answer, it's easier to understand that problem, right? They said that the answer was 2B, which means B is equal to 2B percent times 50. Well, when I convert the 2B percent, I make it 2B over 100 times 50. And yes, that's the answer. You can see that's going to be an equation, which means we could have, the best way to really solve this was to back solve it. Really is. The best way to solve number 5 is to back solve it. In fact, these percent problems, I noticed, I took a quick look at this earlier, and I noticed an awful lot of them are going to be back solving problems. Let's look at 6. 8 is 1/3 percent of what number? Give me an equation.
This one I'd use the percent, so 1/3 percent equals 8 divided by the whole number, the number we're looking for. Oh, 8 times?
Well, now hold on. They're saying 8 is 1/3% of what number? The x goes there. Let's be consistent here and let's write it exactly as they say it. 8 equals 1/3% of multiply what number will let x be the number. Now to solve this equation you have to get rid of the percent sign. So what do I do?
It'd be 33%. 0.333.
We got to get rid of the percent sign. How do we get rid of the percent sign?
Multiply it by 100.
Divide it by 100. Remember, if I say x%, that equals x over 100. 5% is equal to 5 divided by 100, or 0.05. So whenever you're converting a percent to a decimal, divide it by 100. So what I really have is 1 over 300 times x. X is equal to 2,400. In other words, what's confusing here is that most people would probably do what you did, which is to take 1/3% and convert it to 0.333. But that's not what it is. Notice that 0.333 is 1/3, which is 33 1/3%. So they're kind of trapping you by calling it 1/3%. 1/3% is actually 0.00333. That's what 1/3% is. All right. That would have also been a good back-solving problem had they given us multiple choice. Probably the reason they didn't is because they realized that would have made it a little too easy. So how are we going to solve 7? We can do it algebraically, or we can do it how?
This one will be back solved also.
This is a perfect back-solving problem. The reason it's perfect is because we know for 100% we're going to know which direction we have to go. We're going to know if we pick one and it's wrong, we're going to know that it's either higher or lower. In fact, there's something else about this problem.
Yeah, we know D and E are not going to be correct.
Exactly. So we're going to solve this problem on one attempt, maximum. Try B, and then you'll know whether it's A, B, or C.
And it's going to be C.
Okay. So you got 125% of 85 was less than 110?
Yes.
So you knew it had to be C. Okay. That's a little extra gimmick I've noticed in a few of these problems, where they give you a little additional break by giving you numbers that you know can't possibly be. And it's worth noticing that, because notice that the typical back solving, we usually have to try 2 of these.
Right.
It's only going to be, well, remember I told you once that the book says C and it's wrong? Well, here's why it's wrong. If you guess C on a back solving problem, you're only going to get it right 20% of the time, right? On the first time, on the first guess, you get it right 20% of the time, and then second guess, you get it right 100% of the time. Correct? Because after you try C, if C isn't correct, you know higher or lower, and then one more time is going to tell you what it is.
Okay, yeah,
Well,
that makes sense.
my method, where you try B or D, you get it right 40% of the time. You get it right whenever B is the correct answer, and if it's less, you're going to get it right whenever A is the correct answer. And on the second time, you're going to get it right 100% of the time. So which one of those is more efficient?
Yours.
Got to be.
B and D.
Got to be. So there's a little probability problem mixed in with our percents.
And I need help on those too.
Well, that's actually a pretty good probability problem. Somebody should put it on the test and submit it. Maybe they'd realize they're wrong on the other. Okay, at Bernie's Bargain Basement, everything is sold for 20% less than the price marked. He buys radios from somebody for $80. He wants to make a 20% profit. So what should he mark it as?
Okay, so Bernie's Bargain Basement, everything is sold for 20% less. So once again, I'm going to say stack solving.
Absolutely. Again, because you know the direction you're going to have to go. Even if you don't know the direction, back solving can be the way to go. Just because this is a little tricky setting it up algebraically.
Okay, actually what I did was I went ahead and did 20% of the 80.
Well, if you're back solving, you want to start with the answer, B, $100.
I know, and I was going to say that on this one, I think I got the answer right, which is $96. And what I did was took 20% of $80, and he's going to mark it down. I may not have done it right.
No, you didn't. What we want to do is start with an answer and then work through the exact problem. Okay. So let's start with 100. That's the marked price. Okay? Okay. So since everything in the store is sold for 20% off, that's going to sell for $80. If we mark it 100, it's going to sell for 80. Well, he's not going to make any profit at all if he sells them for 80 because he bought them for 80. So we know that's not a high enough price. So now let's try $120. Well, what's the markdown from $120? $24. So we'd sell it at a listed price. I'm sorry. This is what the customer would pay. If the list price was $120, the customer would pay $96. And does 96 represent a 20% profit? Exactly. 18/16 is 0.2, which is 20%.
Okay.
This one's a little hard to understand, actually. I think that's probably why you went wrong in the first step. Although this is a very typical real-life situation. This is exactly how they operate these kind of places. They mark stuff down, and then they still have to make a profit after they've marked it down. But
well, then people think they're doing a great deal.
That's right. They think it's 20% off of what he paid for it, but
it's not.
No, it isn't, is it? $277. Uh-oh. Like my camera wasn't so steady here. Okay. Can you read that okay, or do you need me to read it out loud?
No, I can read it.
Okay. What method should we use here?
Oh, I hate these kind of problems. I'm not good at word problems.
Well, I think the best thing you can do is to start off telling yourself, am I going to algebraically solve this? Am I going to back solve it? Am I going to pick numbers and then back solve it?
I don't think back solving on this one.
Right, not by itself. But notice they haven't given us any numbers. They're not telling us how much she deposits each month, which means we can make that up and make up a nice convenient number.
So we can say like $10 a month. Or would we want to go by 12?
No, 10 should work fine. So if she put 10 a month in, that means she puts 120 a year. And that's at 10 per month. And then since she's not going to have 10 in November and December, then she has to deposit $120 in 10 months, which is $12 a month, which is how much of an increase? Percentage-wise, over 10.
$2 over 10?
Uh-huh.
So 20%.
And that's the answer. Yeah, this would have been tough to do algebraically. But once you put some numbers on there, then working with numbers is a lot easier than working with percents. And the moment you switch everything to some numbers, then you can easily come up with the percents.
Yeah, that makes sense.
Mm-hmm.
And I have this thing, I see word problems and immediately freeze up.
Well, the other very first suggestion I make to everybody on word problems is always start in the same place. Define your variable and know exactly what that is.
Okay.
Once you do that, you'll be amazed at how easy word problems become. As soon as you're looking at a variable and you know what that variable is, you know what letter it is, then it becomes so much easier to formulate an equation. And that's the secret, is how to get that equation. Well, the first step with that equation is to figure out what your variable is and what it means.
Okay, this one looks like a back solving.
Correct?
Okay, so we're looking for the, first off, for the, I don't know. See, I don't understand
Okay.
this.
All right. Let's go ahead and pick numbers on this also. Let's try to notice something else about this that you noticed on the previous problem. If they increased the price of bread, are you going to be able to buy more or less than 300 loaves?
You're going to buy less.
Right. So we immediately can rule out D and E, and now that makes it a beautiful back solving. That means we're going to be able to solve it in one step.
Okay.
Okay. So let's make the price of bread $1. and they increase it to $1.20. Well, $300 used to buy 300 loaves of bread. Now how many loaves of bread is $300 going to get you?
250.
Right. Divide by $1.20, you get $2.50. So there's the answer, and we didn't even need to back solve.
No.
Picking numbers really was the key. Because once you put it into real numbers, for some reason I think the brain more easily recognizes the problem. In other words, I know what happens if I've got $300 in my pocket and I'm going to the store to buy something, and on the way to the store they up it by 20%. I'm going to get a lot less of that thing, whatever it was I was buying. Okay. 11. 1 micron equals 10,000 angstroms. Then 100 angstroms is what percent of 10 microns?
And unfortunately, I'm experiencing a problem again.
Well, this is a hard problem. Don't feel bad that you're not knowing what to do here. First of all, let's figure out what 10 microns is. In other words, let's kind of start from the back. I'm not going to do this algebraically. We can do this by back solving, clearly, but we need to know how much 10 microns is. How many angstroms is 10 microns?
It would be 100,000.
Okay. Then 100 angstroms is what percent of 100,000 angstroms? 100 angstroms is what percent? Well, let's put it as a ratio. Let's first of all determine what fraction it is.
It would be 0.01.
So it's 1/1000th, which I could write like that, which is what percent? Right. When you came up with 0.01, how did you do it? Did you cross out zeros? Did you do it on a calculator?
I did it on a calculator.
And you put 100 divided by 100,000?
No, I did 10,000.
Ah, okay. All right. I have no problem with doing it on a calculator. That's probably the best way for you to go.
Just need to make sure you're in the right numbers.
Yep, need to get the right number of zeros. Yeah, because the calculator would have given you that, and then I know you know how to convert that to a percent. So the key really is to figure out what 10 microns is and then find the ratio. 100 is what percent of 10 of 100,000? Is it clear to you that when somebody says 5 is what percent of 500, that what you have to do is start with that ratio?
Yes.
Convert it to a decimal, convert it to a percent. Okay. Number 12. How are you going to solve number 12?
It would be algebraic.
I would pick numbers.
Pick numbers?
You see why? In other words, they haven't given us any, first of all. So I could pick whatever numbers I want. I'll just make twice as many girls as boys. The reason it's a pick numbers is because I can figure out all of these. I'll end up with numbers, and once I end up with a ratio, I'll know what percent, how to convert it to a percent. So there's no real need to do much algebra here. I mean, there might be a need to evaluate the expressions. So what two numbers would you pick? How many girls and how many boys?
Probably 45 boys and 90 girls.
Now, notice that the number of girls times 30% has to be a whole number, and the number of boys times 45% has to be a whole number in order to conform with the second sentence. In other words, we could pick 100 girls and 50 boys.
Okay.
But the problem is that 50 times 45% doesn't give you a whole number. Or does it? No, it doesn't. It gives you 5 as the last digit. So we don't want to do 150. So let's do 200 and 100.
Oh, okay.
So this is a good example of, first of all, it's a picking numbers problem, but secondly, it gives you some good insight into how to pick numbers, because the first thing that most of us would try would be 100 girls and 50 boys. And that works for the girls, but then we immediately discover that 45% of 50 boys is a guy missing his legs. So we're not going to be able to use those two numbers. And if we notice that that produces a half a person, then all we have to do is double the numbers we picked, and that will turn into a whole person.
Okay.
And indeed, that's what happens. If we pick 200 girls, then 30% of them is 60 girls. And if we pick 100 boys, then 45 boys. So they've already handed in their book reports. What percentage of the students have not? Well, the percentage of the students, I can do this two ways. I can figure out the percentage of the students that have handed it in, and then subtract that number from 1, or 100. What does this number equal? 105 divided by 300.
35.
So 35% have handed it in. I personally find it easier to do it this way, which means 65% have not. As opposed to the alternative method, which is to figure out that if 105 students have turned it in, then 195 have not. So then I take 195 over 300 to come up with my 65%. Notice the difference in the techniques. In the subtraction technique, I had to take 300 minus 105. That's harder math than figuring out the complement of 35%. That's why I preferred the first way.
Okay.
Let's figure out the percentage of students who turned it in, and then I'll know how to take that minus 100 minus that real easily. A subtle point, probably not even worth mentioning, but I had to figure out why I preferred doing it the first way.
Well, actually, that is it.
Well, I definitely believe in working with as small a numbers as you can. It's why if I give you this problem here, even with a calculator, now let's make this 8. Even with a calculator, you don't want to multiply 8 times 35 and then divide the whole thing by 7. I want to do this first. Now 5 times 8 is 40. I can do that faster than you can do it on a calculator, doing it this way. And the philosophy is that you reduce everything first before. Certainly manually, you definitely would not want to multiply 8 times 35 and then divide by 7. That would take a long time.
Yeah.
Calculator eliminates the value of doing some of those tricks, but $13.
Okay, so art dealer. Okay, well, it increased by $9,000.
Okay.
So 9,000 divided by the original price.
Exactly, and that's the key, is to find percentage increase or decrease. You always take the change and divide it by the original.
Okay, and then times 100%. Well, 100.
Well, yeah, you convert this to a percentage. That converts to the number 9. Move the decimal point 2 spots to the right to get 900%.
I think that's the first one I was able to read so far this morning.
Well, we're making progress then. What percentage increase do we have if we go from 80 to 120?
It's going to be 40 over 80.
Okay.
So
what percentage decrease do we have if we go from 80 to 60?
It's going to be 20 over 80. So 1/4.
Right.
25.
Right. And this is why investing is so much fun, because if you start with $100 and you lose 20%, it becomes 80. And now to get it back to 100, you got to make 25%. In other words, if you make 20% on 80, it only goes back up to 96.
Ah, true.
So when they say the stock market dropped by 50% and then went up by 50%, it did not recover its losses. It has to make a higher percentage gain to recover the same percentage loss. Now, some of these, they force you to do them algebraically, since it's not multiple choice. And what piece of information is in that paragraph that prevents us from picking numbers?
That the tag was $45 too high.
Exactly. That means it's exactly some number. So we really are forced to solve this algebraically. So since it's a word problem that we're going to solve typically as an algebraic problem, what's our first step?
To find what it is, the variable that we're looking for.
Okay, always look to the last sentence for that. If you follow this methodology, these all become a piece of cake. You look to the last sentence, what's the original price of the jacket? Bingo, X equals original price. Okay, now let's start from the front of the sentence. On one jacket, he accidentally raised the price by 15% instead of lowering it. So what price did he put on the jacket?
He put 85. Oh.
That price right there. In other words, whatever the original price was, he put 1.15 times it. What should he have put?
85.
0.85. Okay. As a result, the price of the tag was $45 too high. So what equation can I write?
Equals X plus 45.
Well, if I took the price that he put on it and I subtract the price that it was supposed to be, that's got to equal $45.
I am really good at these.
Well, these are tough. These are tricky. Switching from decimals to percents and back and forth is the easiest thing in math. But that's not to say that they can't make these very difficult problems. And that's the only reason I said when I first looked at this section I thought it was going to be easy, because that's all percents are switching back and forth between decimals and percent. But they've built in a bunch of word problems combined with percent problems.
Yeah, I'm glad that you're going over these.
Yeah, me too. Absolutely. I see. Well, as soon as I read them this morning, I realized I do need to go over these, just because they're hard. Okay. So
yeah, these are some of the worst ones.
They are, actually. They are. I agree. They're some of the toughest we've encountered. So you know how to solve that equation? Easy enough?
Yes.
Okay. Okay, number 15.
Wow, this is another difficult one.
You know what this question reminds me of is average problems. Let's talk about average problems for a moment, and maybe you'll see that connection. If I tell you that I got scores on a 100-point exam, my scores were 60, 70, and 80, my first 3 tests. What do I need to score on the 4th test so that I will average 75?
Okay, the variable will be x, so it'll be 60 plus 70 plus 80 plus x equals 75. And then solve for x.
That would, you'd have to divide that by 4. That's the way it would be set up.
Okay.
Okay? The key to solving average problems, and by average I mean arithmetic mean, is to know that you need the total. In other words, the way I prefer to solve these, although you set that up algebraically really quick, and but the way I tell everybody to solve these is I say always make it totals. In other words, it's always going to involve totaling these up, which you did. You totaled that one up. But then when I said the average needed to be 75 over 4 tests, what I would prefer to do is take 4 times 75. That means the totals have to be 300. So instantly I know that 90 is what I got to score on the 4th test.
Oh, okay.
Okay? So just know that when you solve average problems, you have to come up with totals. That's the key to solving all average problems, is to come up with totals. Well, this is a similar problem. If he answered 75% of the first 60 questions, how many did he answer correctly?
$40.
45.
Oh.
75% is 3/4 times 60. Divide 4 in the top and bottom. Okay. So he's got 45 correct. And there's 20 more questions. What percent of the other 20 questions first of all, in order to get 80% on the exam, how many questions right is he going to need to have?
I don't know.
Well, there's 80 questions. To get an 80% on that test, how many questions do you have to get correct? If there were 10 questions, yeah, you take 80% times the number of questions. So you'd need 64 questions correct. In other words, we do 80 times 0.8. So to get an 80% on the entire exam, he's got to get 64 questions correct. Well, he's gotten 45 correct, so how many more does he need to get correct?
19.
Out of how many more questions?
Out of 20.
What's that percentage?
95.
Okay. So it really was an average, an arithmetic mean question disguised as a percent question. All right, let me go to the next page. I think I need it quite that big. Can you read that?
Yes. Yes.
Okay.
Well, the same number of or should I pick numbers?
Let's pick some numbers.
Well, we can even start with 3 and 5.
Yeah, absolutely. That's so that we have 3 red and 5 blue, correct? Yeah. Okay. And now pick a number of red and blue to add.
8.
So now we have 11 and 13. So the ratio of the red to blue marbles now is 11/13, and quantity B is 3/5.
Okay, so yeah, quantity A is larger.
Yeah. This is the same concept as which is bigger, 4/5 or 5/6?
5/6.
Notice that we added 1 to top and bottom.
Yes.
So it doesn't matter what we add. If I added 2 to top and bottom, I would have 6/7, which is also bigger than 4/5. So if you add a constant to the numerator and the denominator, it increases the fraction, the size of it.
Sorry, I was writing.
Oh, that's okay. And when you see a 3 times ratio like that, add those numbers up. What do you get?
15.
Okay, 15 is very divisible into 3,000. So we should be able to split that up pretty easily. In other words, if I said that one got $2, the other got $5, and the third one got $8, which is in the proper ratio, that would total $15. Well, I need everything to total $3,000, so I need to multiply each of these by 20. So this would be $40. This would be $100. And this would be I didn't mean 20, I meant 200. Hold on. 300 is to 15. That is 200 times. Okay, so we've got $400, $1,000, and 200 times that is $1,600. And those three numbers add to 3,000. Okay?
Okay.
So the difference between the largest and smallest is what?
1,200.
Same quantities.
You made that one really easy.
Well, good. Okay, because algebraically it can be a little more confusing. However, whenever you look at these kind of triple ratios here that are using colons, know that you got to add those numbers up. In other words, if those numbers add to 15, then the first guy got 2/15 of the profit, the next guy got 5/15 of the profit, and the third guy got 8/15 of the profit. So I could have done it algebraically by just multiplying that by $3,000 and this by $3,000 and subtracting the two, you're going to get $1,200. I took a bit of a shortcut by recognizing that 15 was a very nice factor of 3,000, but that's probably really, I shouldn't have really done that. I should have done it the second way. You still have
that was helpful too.
Okay, all right. But the key is adding those up and knowing that 2 divided by the sum of those numbers is the percentage that that first guy gets, or the fraction amount that that first guy gets. 2 divided by 15. Okay, 21.
When you know what, we're at 10 o'clock.
Oh, okay. Well, why don't we end with 20 then? And we'll pick up with 21 tomorrow.
That sounds good.
Okay. Angela,
Okay,
I will talk to you in the morning.
Okay, bye-bye.
Bye-bye.